Today we'll be looking at basic multiplication using assembly, and let's get straight into it. So I'll go ahead and create a file, and I will open it using nano. So nano followed by the name of the file. I will name it mule.s. Now here we'll go ahead and initialize our normal section, so which is the text section. Define the global starting point, start. Then, so I've misspelled this, so global, then followed by the start symbol over here. So in multiplication, the first operand is must be loaded in the register EAX. So the first operand must be loaded on the register EAX. So like that. So let's go ahead, and so the assembly or the assembler expects the first value to always be loaded in a 32-bit register EAX. So let us do it. So move EAX the value 4. Then we will move another value to any other register. So you can use the 16-bit, 8-bit, or any kind of general register. So let me use ECX. So I want to move another value in ECX, maybe 4. Then I'll use the mule directive. So mule followed by ECX, the second operand. So what this will do, it will take ECX, then go ahead and find the EAX register and multiply both of the numbers together. So let us run this program. So we are expecting the value 16, so this must should yield so this should yield 16 after multiplication. But let us compile it and see. So go ahead, nasm -elf32 followed by the name of my assembly, which was a mule, then followed by -o to generate the object file. So I will name it mule.o. Then go ahead and linking, so ld like that. So elf underscore i386 followed by the name of the object file was main.o, then -o our executable main. So it's not main, it was mule, sorry for that, I'm used to main. Then let us use just the same name like that. So as you can see, it has compiled successfully, and we'll have an executable program here. So let us try running it. So I will use GDB as usual, then the name of the executable, so like that. So let me zoom out just a little bit, or maybe I can so let me exit. So let me see something. So okay, let me exit and let us try again. So GDB followed by, so I will go ahead and use okay. So GDB, sorry for that. So main or mule. Then we'll go ahead and type layout ASM. So layout. So no debugging symbols for mule. So what's going on here? So we have that one. So let me try something. So GDB followed by mule like that. Is it I typed correctly? So let me see it. So it's not mule like that. Then we'll go ahead and just maybe use layout ASM. So let me delete. So layout ASM, followed by the breakpoint, so break at start, then just run the program. So run, then we'll step into each individual instruction. So step I until we reach the interrupt. So after multiplying ECX to EAX, the result is stored in EAX. So let us see what value is stored inside EAX. So info registers EAX. So as you can see, we have the value 4. So we've done something. So we didn't write our interrupt. So maybe we can step again like that and just use, or let me see something. So sorry for the confusion for today, but let us see. So we haven't interrupted the program to return the control back to the Linux kernel for it to execute the command. So don't forget including the int 80h. So first to load, the first value should always be loaded in EAX register. Then you can use another general purpose register to load your values. So let us save it, run it again, or compile it again. So I will use this one, then I will link it, just link it, then we'll go ahead and maybe open GDB. So GDB mule. Now we'll use the layout ASM, then we'll break what point at start, then run, then go ahead and step into each instruction. So step I until we reach the interrupt. Then let us see what is stored in the register EAX, because there is we expect our result to be stored in that place. So EAX, so you can see the value 16 is stored here because 4 multiplied by 4 is 16. So let me exit. Let's go back to our source code. So source code over here. Now there is another directive called imule. So imule. So there is the mule and the imule. So mule is for unsigned. So let me maybe I can write a comment here. So mule or multiply is used to multiply unsigned numbers or values. So this meaning only positive or non-negative numbers. So non-negative numbers, and then there is another directive called the imule. So this is used for signed numbers, multiplying signed numbers which are, so we can say which are negative numbers, just like that. So maybe we can go ahead and maybe use the imule. So in here, so we'll just say maybe -4 over here. Then instead of mule, I'll use imule like that. So let me put this one here. So these are comments. So these are comments, don't worry about them. So the real point is here. So I'll repeat again. So the first value is expected to be loaded in the register EAX. Then you can load another number or operand in another general register. Then you use the mule or imule to multiply, and not you won't use EAX, so we'll use ECX, the source. So you just use the source, the second register, then the result will be stored into EAX. So let us see the result. So let me not be lazy, just type it. So dash f else 32 mul dot s minus o mul dot o. Now I've written so mul dot o like that. Then go ahead and linking, so ld minus m elf i3 86, yes, then followed by the name of, which is mul dot o, then o minus o mul, like that. Then let's go ahead and open our debugger, mul, that. So go ahead, just type layout asm break at start, run. So we go ahead and step into each instruction. So step I till you reach the interrupt, so we can see what is stored inside the EAX register. So info registers EAX, so you can see it's negative 16. So you can use mul for signed or unsigned numbers. So imul is for signed numbers, so negative numbers. Mul is for positive numbers, but also you can use mul for negative numbers also. But we'll be seeing, we want to start in the basic level, then we'll go ahead and just build or just experiment and learn more. So there is more to the multiplication instruction than what I've shown you, but I want to, we start at the basic level, then we go advancing and understanding more and more of that instruction. So that is basic multiplication. So basic multiplication. So we'll go ahead and say that the first value in multiplication must be stored inside the register EAX, a 32-bit register. Then you can move another number that you want to multiply it into any other register. So it can be ECX, EDX, or DX, or AX. So for now I've been using EBX. So EBX, then you go, or ECX you can use also. So I've used ECX. Then you apply the mul or imul instruction and just place the second register or the source register. So this is what is referred as the source register. This is the destination which stores the final value. So over here now the result will be stored inside the AAX register. So that's all about or just that's a basic overview about multiplication in assembly. So if this has been helpful to you, just leave a like, subscribe, share the video, turn on the subscription or the notification button in order to be notified whenever I drop a new video. So see you on the next video.